So in this case, we can divide this kite, the diagonal with HF, and then because this triangle is similar to this triangle. So there are small triangle and big triangle, and the ratio of similarity is 1 to 2 because G and E are midpoint. So that means if the length of AB is 1, uh, this length is 1/2, and this length is 1/4, and this length is half. So once again, these two triangles are similar, and then the ratio of similarity is 1 to 2. That means if we make this another diagonal of the kite, this half of the horizontal diagonal, the length is 1/3 of this 1/2. So 1/3 of 1/2 is 1/6. And then now we can find the area of the shaded region because the base is 1. And so this means the horizontal diagonal of the kite is 1/3. Uh, and then after you multiply these two diagonals, it's divided by 2. So what's the area of the shaded region? Can you multiply
Hmm?
these
Yes.
three? Yeah.
1/6.
Yeah, 1/6. So the answer is E. And in 17, so we can think of the triple, which makes sum of the two, or makes the value on the remaining die like this. 1, 1, 2 is 1 triple. 1 plus 1 is 2. Yeah, so the maximum is 6. So after making these triples, uh, if there is a common number in the triple, the number of arrangement is 3. And if there are no common numbers among triples, the number of arrangement is 6. Yep, so when you add all these numbers, how many cases are possible? So there are 6 and 6 and 3 and 3. So that means the total number of cases is 45. And then when you roll the 3 dices, the number of cases is 6 cube, so 216. So when you simplify this, which one is the answer from the choices?
Hmm?
Yep,
Mm,
yep.
For 15 over 72.
No,
Oh,
you can simplify more. Yeah.
B. Oh,
Uh,
wait, no. Sorry. Oh, D.
yep. And if we make the square in number 18, so the y vertices are 0, 1, and 4 and 5. So we can think of this type of square like this, and that means we can make another square outside this square like this, and uh, because these two triangles are congruent, uh, if this length is 1, this length is also 1, and uh, the length of this leg is 4, so that means the length of this leg is also 4. So now, using Pythagorean theorem, what will be the area of the inside square?
Uh,
Yeah,
mm, 16. Square root is, it's 17.
yeah, 17 is the answer. And number 19. So we wanna make this diagonal, and we wanna find the portion of xy contained in the third cube, the side length 3. So the whole length of this xy is this length is 10 and 4 and 4. So we can make the Pythagorean theorem. So xy is square root of 10 squared, 4 squared, and 4 squared. So 132, square root of 132. If we simplify this, 2 times square root of 33. Yeah. And then for the portion contained in cube 3, because the length of the third cube is 3 and the sum of the total length is 10, that's the 3/10 of this 2 times the square root of 3, 33. So if we multiply 3/10, yep, so what's the answer from the choice? So can you find the value in the choice? That's this 3/5 of square root of 33. So the answer is A.
Okay.
Yep. And number 20. So if we make the pattern, 8 times 8 is 64, and 8 times 88. Can you find the product? I mean, you can use calculator. I mean, what is 8 times 88?
704.
Yep. And then increase one more 8. What is 8 times 888?
7,104.
And one more means 8 times 8,888.
71,104.
71,000. Yeah, 100, something like this, right? Because it's like the 64 is kind of being added in this pattern. If these are the k digit, so the pattern is when this is the second number is a four digit. This middle value is 2, and when the second number is 3 digit, the middle value is 1. So the pattern is if the second number is k digit, the middle number is k minus 2, and then we are going to add 4. And the sum of this is 1000. So what's the value of k when you solve this equation?
Okay.
Yep.
Mm, uh, oh, 991.
Yep. D is the answer. For number 21, so these two lines have the same x-intercept, so we can make these two equal to 0. Oh. So let's say ax plus 5 is equal to 3x plus b, and they are both 0 at the x-intercept. So that means for the first equation, x-intercept is minus 5 over a, and for the second equation, minus b over 3. So this means a times b is 15, and because a and b are positive integers, there are 4 possible cases: 1, 15, 35, like this. And for each case, if a is 1 and b is 15, the y-intercept, x-intercept is minus 5. And for the second case, the x-intercept is minus 5 over 3. Third case, minus 1. Fourth case, minus 1/3. So when you add all these 4 numbers, what's the sum of these negative numbers? When you add all these 4 numbers,
minus 8.
yeah, minus 8. Yeah. And for number 22, yeah. There is a rectangle, and the length is 2 times the width. Yeah, so let's make the rectangle. And so 20 and 10.
200.
Oh, you already have. Oh, okay. Your area is 200. And then let's put E on CD, and like this. and the angle of CBE is 15 degrees. And we wanna, that's E. This is E. And we wanna find the length of AE when we connect A and E. So what we are going to do is, yep. So I mean, if we use trigonometry, this length is the 10 times tangent 15 degrees. Yep. This means the remaining segment will be 20 minus 10 times tangent 15 degrees, and this one is also 10. So we can use Pythagorean theorem. So length of A is the sum of the square of these two. But first, so let's find the value of tangent 15 degrees. 15 degrees is the difference between 45 and 30 degrees. So if we use the formula for the difference in tangent, we can use this formula. Do you know the value of tangent 45 degrees? Tangent 45 degrees, do you know? Or you 1. How about, yeah, so tangent 30 is the 1 over square root of 3. So if we use these values, and if we rationalize this, yep, so this is the value of tangent 15 degrees. Okay, so that means this value, if we put this value, the 20 cancel. So actually that's 10 times the square root of 3. Yep, so now when you use the Pythagorean theorem, what's the length of AE when two legs are 10 and 10 times the square root of 3? So if we say the hypotenuse is x squared is like this.
Around 100 plus square root, it's 20.
Yep. And for number 23, let's make separate figure. So now the length is square root of 3 times the width in this rectangle. So let's say width is 6, so the length is 6 times square root of 3. So the so each of these will be the 2 times the square root of 3. So when we fold this rectangle using this crease, that means this crease will be the perpendicular bisector. After this point, move to the other side, like this. Perpendicular bisector means this one should be the perpendicular and these two lengths should be the same. Because this point is the center of the rectangle. The center of the rectangle divides the diagonal with the equal length. So that's why these two have the same length. And then one special property for this rectangle is that with the ratio of this 1 to square root of 3, this angle is 30 degrees. Yep, this angle is 30 degrees, and that means this angle should be 60 degrees. So the length of the diagonal is 12. So 6 and 6 squared over 3 makes this 12. So that means this length is again 6. And and then we can also reflect this point using this crease. So once again, the extension of this crease will be the perpendicular bisector of these 2 points. So after folding, the total figure after folding will look like this. This red line is the total figure after folding. And because this length is also 6, if we connect these 2 points, these two triangles are congruent because they are both the right triangle, and the hypotenuse is common and at the same leg. And the length of hypotenuse here is 4 times the square root of 3. And because this length is also 4 times the square root of 3. These are also right triangles. So actually, all these 4 right triangles are congruent. So after folding, it will be composed of these 4 right congruent triangles. So the area after folding, if that's B, that's 4 times the area of each triangle is 6 times square root of 3. And for A, the area of the rectangle is 6 times 6 square root of 3. Yep, so now what's the ratio of B to A?
B to A.
I mean, you can cancel these two
4
because
over 6.
yeah, and then you can simplify further. 4 to 6,
Oh, 2/3.
2 to 3. Yep, so the answer is C. Twenty-four and 5. So let's make some sequence according to this rule. So if we make the group with listed and unlisted, these 4 numbers are listed and we are going to skip 1. That means 5 is not included. And the next 5 will be 6 to 9. No, 6 to 10. And then we are going to skip 11 and 12. And the next 6 is 13 to 18. That means we are going to skip 19, 20, 21. So if this pattern continues, let's say this is group 1 and group 2 and group 3. So in group N, so the first group has 5 numbers and 1 is skipped, and second group has 7 numbers, and third group has 9 numbers. When you think of the difference of the less numbers, so that means in nth group, group N will contain the 2n plus 3 numbers, and among them the n number will not be included. So that's the pattern. So if we add all the numbers in the group, that means we are going to add these numbers 1 through n, and because that's arithmetic sequence, to find the sum, we can add the first and last term. So the first and last term sum is this, and then multiply n and divide it by 2. That's the total number in from 1 through n group. And then we are going to subtract the numbers not included in the counting. So the sum is the 1 through n. So that's this. The sum 1 through n is. And then this number should be less than or equal to this 500,000. So when you solve this inequality, you'll be able to find and the value of n. So when you do that, when you simplify the left side, yep, so this is less than or equal to 500,000. And then when you look at these choices, they all have this 996,000. So we can assume, we can reasonably think that n is the 996. So let's just see what happens when n is 996. That means 996 is the difference between 1004, and when we add 7 to 996, that becomes 1003. That means the n plus 7 is 1000 plus 3, and that's divided by 2. So when you open the parentheses, we have this expression, and when it's divided by 2, so this means from this 500,000, it lacks this the 506. There will be the less number in the group 996. And to fill this 500,000 number, we need to add this the lacking this 506. So when we add 506 to 996,000, that will make this 506. So the answer is A. And for the last problem, so let's make a list using this power of 2 and the powers of 5. So if we use powers of 2, so these are some list of the powers of 2 and 5. So between powers of 5, there are two numbers of power of 2 at some interval, and at this interval there are 3 powers of 2, and this interval is the case we want. because in this interval there are three powers of 2. 2 to the power of m, m plus 1, and m plus 2. So we want to find the number of intervals which contains these three powers of 2. So let's say the number of interval is y, and the interval which contains just two powers of 2, the number is x. And then the last number we're going to look at is this 5 to the power of 867, and this 2 to the power of 2013, like this. So when we add this interval made by power of 5, that will make the sum of x and y. And the number of interval is this 867. And for the number of interval made by power of 2, 2x, we are going to multiply this 2. And for y, we are going to multiply this 3 because it contains 3 intervals. And the sum of this number is this 2013. So if we multiply 2 to the first equation, and then when you subtract the second and third equation, what's the value of y? Yep. Can you find the difference between these two numbers? Can you hear me? Can you? Yep.
Oh, sorry, my computer crashed.
Okay. Can you see the screen now?
Yes, I can see the screen now.
Can you find the difference between 2013 and 1734?
2013. I got 279.
Yep. So that's the number of intervals contain the 30 powers of 2. Yeah. So the answer is B. Yeah.